Time for another review video. This time it's on climate and not energy sources like last time, though those principles may still carry over. So let's see what you remember. Back to the iPad, let's see how it works. I'm still confused on how to find the mass of an element using the periodic table. I think you meant charge. And if that's what you mean, I posted a video. It's on Canvas. If you still have questions, send me another email. How does climate work? Could climate stay the same year-round? Well, climate, remember, is just a lot of weather data put together. We're talking like years and years, 30 plus years is what we normally consider to be climate data. So how does it work? Well, it's just the averages of all of the weather that happens. So how does weather work? Well, we'll get into the specifics of that a little bit later, but it's temperature and pressure and winds and specific heats and all sorts of things like that. Just know that it's a large set of data that we use to find averages. Could it stay the same year-round? Sort of. It kind of already does. Remember, it's not like it's something that changes. Climate's a long-term thing. But I think you're asking, could climate never change? And theoretically, technically, I guess so. But that would require a lot of crazy math and physics and planetary motion to happen in the right order. Could you elaborate more on how climate is different than weather? Kind of just did that. Weather is what's outside the window. It's what's going on right now. It's whatever's happening outside when you're watching this. Climate is all of that weather data over years and years and years and years added together. Weather is right here, right now. Climate, long-term, big picture. What is El Nino and La Nina in detail? Do you have to help, or do you have a way to help remember the difference between El Nino and La Nina? And can you give a good definition for them? I'm not going to get into the super specifics of this. I didn't have time to do it in class, so I'm not going to do it on the test. But the easiest way is that El Nino is when the eastern Pacific warms, so closer to California. La Nina is when the western Pacific warms. And what that does is change temperature and precipitation patterns because it changes pressures. You don't really need to know that. Just know that there's seasonal patterns that are somehow related to climate that we're not quite sure yet. Know the very, very basics, what's on there, other than the little tip that I just gave you. That's kind of the best way to remember it. Will there be elevation questions on the test? For example, if the temperature in sunny Knoxville is the thing I asked you on the notes, I would know how to do them. Are the graphs we did last week going to be on the test? The ones that had different temperature and rainfall, and could you go over the different types of climate? You're talking about climatographs. Climatographs show the average temperature and rainfall over a monthly period over about a year. I would also study those, and I would make sure that you're looking at the right y-axes and know which one's the line and which one's the bar, and might not be a bad idea. Can I go over the different types of climates? We'll come back to that. What is MT? What are the different names for air masses? Can you explain more about air masses? Could you explain air masses and the names again? Is there a trend for the same climate over large areas? For example, does the West have continental climate? Is there a good way to remember the differences in air and air masses? Okay, so it seems like you guys need to know about air masses, and I would know about air masses. So the best way to do it is just sit down and break the different components. M is maritime. Maritime formed over water. Water is going to have more humidity in it. It's going to be wetter. Continental, sea. It's going to be forming over land. That's why it's called continental. It's not going to have as much moisture content. It's going to be drier. Then we have polar, P. It's going to be formed at higher latitudes. It's going to be colder air. It's going to be kind of from up near like northern Canada in our case. Do not worry about Arctic. And the last one is tropical. Tropical is warm. It's hotter air. It's going to be formed more towards the equator and the tropics. So when you combine those things, like MT, like this question's asking, is maritime tropical. That means maritime, it has moisture. Tropical means it's warm, so think rainforest. CP, continental polar. Continental means it's formed over land, so it's dry. P means polar, so it's cold. Just add the different definitions together and you've got it. We'll go back over that again in weather too, but just know the basics for now. You don't need to know where they come from yet. Anything about the ocean or currents? Know that currents are what help keep climate regulated. The warm water in the equator gets pulled up to the poles, and then it drops down due to differences in density. Remember that density is what drives these currents. Once that warm water, which is less dense, and that's why it's on top, sinks to the bottom because it's colder, then it becomes more dense. It eventually gets carried back to the equator, and where it warms back up because of all that direct sunlight, it goes back to the surface because it's less dense, and it starts to recycle. This whole circulation process of the currents helps keep climate regulated and helps let it be what it is today. Also know that when we add carbon dioxide to the oceans, we get carbonic acid. The more carbon dioxide we add, the more acidic it becomes, the worse it becomes for the things that live in the ocean. Do you have an acronym for the different types of climates? I have trouble remembering the names of the climates and how to classify them. Could you go over this in the video? I don't have any questions specifically, but can you go over the different types of climates again? Could you go over the different types of climates again? The differences in climates around the world. Okay. I would study that page. I'm going to go over them in some, brief explanations here, but just look over that page. So let's see if I can remember them in order. The first one was tropical. Tropical climates are typically going to be found near the equator. We think of like rainforest being a great example of this. Typically going to be MT, maritime tropical air masses, wet and warm air masses. Lots of rain, typically hot all year round. Dry climates. You can think of them like deserts, going to be typically warmer with lower precipitation. So desert, it's not going to rain a lot, but it's probably going to be pretty hot there. It covers about 30% of Earth's land, not surface, land. Next is mild. That's what we are in North Carolina. It's what the southern Mediterranean area of Europe is as well. It's because we're near water. It's going to keep us more regulated. Our summers are going to be cooler. Our winters are going to be warmer. We're not going to have a huge variation. Yeah, I know it gets hot in the summer and cold in the winter, but compared to some other places like Canada, for example, or Central Asia, which is a continental climate, it has more extremes. Because they're further away from water, they are not going to be as regulated, meaning their summers are going to be pretty hot, but their winters are going to be really cold. So there's a bigger extreme. Yeah, Canada doesn't get that hot during the summer. It gets about as hot as we do, but Canada gets really cold during the winter. That's why it's continental and why it's not mild. And then the last one was polar. We find that at the poles. And we can also sort of see this polar thing at places called highlands. This is when it's really cold and not a lot of precipitation. It's kind of like dry, but it's cold instead of hot. And highlands are on top of mountains. Highlands, that's where they get the name from. You can maybe come up with an acronym. I don't, unfortunately. I'm sorry. I don't have an acronym. Maybe that's something I can work on when we continue and when we have to study for the final. But I just remember them. It's one of those things I just know. Only because I studied. It's not like I just inherently have the knowledge. All right, let's see. Do we have to remember the different places where climates are? Know what we are. Can you go over the carbon cycle? Will there be question about the carbon cycle? So we're going to hit the carbon cycle in more detail in biosphere. Right now, what I need you to know about the carbon cycle is that it's what cycles carbon through the ground, through the air, through animals, through plants. It's how carbon continues to move. You probably learned about food chains before, and you learned that if the energy of the food chain and the food web stops moving, then we don't have the continuation of living things. Well, the carbon cycle is kind of like the food chain or the food web, but for carbon. So it's what, when plants die or when animals die, it decomposes, it goes into the ground. The ground, things in the ground, bacteria, all sorts of stuff kind of break it down. Carbon becomes available again. Plants use it. They grow using that carbon. Then they breathe out oxygen, which lets us breathe. We give out carbon dioxide. It's just all the different ways that carbon can move throughout its different forms. What are some examples of natural climate change? So, Milankovitch cycles are a term that I would definitely go study, and that's things like the natural change in eccentricity and the obliquity, which is the tilt, and it's the natural things like ice ages, which happen because of the Milankovitch cycles, or volcanic eruptions, which are only short-term effects. All these things are natural climate changes, and we know that they do happen, and we know that they can affect it. However, we can measure all those things and determine that while they do happen, and while they have happened in the past, and while they will happen in the future, what we see right now, this anthropogenic change, which some of you asked about, and I think you're more clear on now that we've done through a review day, it's not that. The carbon that comes out of volcanoes is not the right kind of carbon. We know that we are coming out of ice ages, but we're going way too fast for it to be natural. It's not just because we want to say that, it's because that's what the scientific evidence backs up. You have to be able to back up your claims and science, otherwise people won't listen to you. So if it's widely accepted, there's probably some really strong evidence that backs up what those people are claiming. You don't get to just make stuff up and lie about it in science and get away with it for very long. Has it happened? Sure, but you get found out eventually. What will happen to other countries if we continue to be inconsiderate and make selfish choices that harm others? Well, it depends on what countries they are. Are they tiny little islands in the ocean? They're probably going to eventually be underwater. Are they countries like the EU, Germany, France, UK? They'll probably be okay. They'll not listen to us or work with us anymore and do their own thing, and that's a whole different geopolitical issue. But big countries with a lot of money will probably be okay. Small countries without a lot of money are probably not going to be okay. Some of you said you weren't sure how this is a national security issue. Well, when we start running out of things, and when we start not having resources, and when we not have water anymore, and we don't have food anymore, well, you start to fight. And when people get angry, they typically look at the people who they think are causing the problems and want to get revenge or help or something on them or from them or do something to them. And if they're looking at the US as one of the big reasons of why they have a problem, there's your national security issue. How do we know anthropogenic change exists? I'm still kind of confused about it, and what are the effects of that? Well, we know it because we can study it. And I know that sounds like the obvious answer, but what does that mean? We look at how much carbon dioxide is in the atmosphere. We look at how much methane is in the atmosphere. We look at how much we're releasing. We look at how much used to be in the atmosphere. We take what we call paleoclimate, which is climate from way back when, which we get from ice cores, and look at what the rates of oxygen and CO2 and methane and all sorts of stuff like this is, and compare it to what modern day totals are. We also know that we're going through fossil fuels at an exorbitant rate, which is not sustainable either for the environment or economically or just due to resources. Eventually, we're going to run out, and in doing so, enough pollution and toxic things from coal, if you remember that, like those heavy metals in the ash, and things like carbon dioxide that comes off of natural gas, will just not create a sustainable thing. Now let me make this clear, because you're asking the rest of these questions are about what's going on with natural changes. Let me make this very clear. The Earth will be fine. The Earth has been through worse. The Earth will probably go through worse later. The Earth's been around 4.5 billion years. We're very young. Humans have been around for maybe 150,000 years in our current form. And we've only been around like us for 2,000, and we've only been using fossil fuels for 250. We're a speck on the Earth. The Earth will be fine. The Earth where we can live will not. Remember the difference. What is the most harmful thing that humans do that hurts the environment, and what do you think the best fix for climate change is? Well, it's just how much energy we use. It's all the different things that we have to figure out. It's all the different energy we use. It's all the different types of stuff we make and need and want. What can we do? Use less. So recycling, it's not just throwing that plastic bottle in a bin. It's reduce is the first thing. You should just use less of things. Reuse. Change what the purpose of it is. If it's a bottle, use it for something else. If it's a container, use it for something else. If it's a bag, use it for something else. And then recycle is the third one. We just kind of skip those first two, where we don't reduce or reuse things. We just get rid of it and come up with something new. What's the best fix? Change how much energy we use and what we eat. is really the best answer. I'm not saying what you should do personally, but if you want to know what to do, that's kind of what we have to do. What are the chances for the world actually switching to renewable resources? I think the world will eventually switch to renewable resources when people can make a lot of money on it, or we have literally no other options. What are the changes that we can see right now? What are some of the effects that are happening, and what can we do to reduce it in the future? Well, some of you asked about the coral reefs. The biggest thing we can do, and I shared this on my Instagram story, is that we see coral reefs dying. We see sea life dying. We see the oceans becoming more acidic. We see the oceans rising. We see atmospheric conditions deteriorating. We see carbon dioxide and methane levels rising. We see places getting drier. We see places flooding. We see temperatures fluctuating wildly. We see stronger storms. We see bigger wildfires. You get the picture. Like it's you can't hide from this, is what I'm trying to say. You can pretend all you want that it doesn't exist, but it does. And those are all the ways we know about it. How long do I think the reefs are going to last? I don't know. They're going away, and they're going away quick. The oceans are important to protect. Like I said in your class, probably. Phytoplankton in the oceans produce about 50% of all breathable oxygen on the planet. When we start getting rid of what's happening in the oceans, and we start getting rid of these tiny little things that we can't even see unless we're using a microscope that give us the oxygen that we breathe, we're probably not going to have a great time after that. What do you think the biggest thing we can do to help climate change is? Stop pretending it's not a thing and start doing your part to fix it. Good luck on the test.